So today we are going to discuss. I'm starting a new series for GATE preparation, GATE 2026, and in the scenario of GATE 2026, we are first starting the mechanics chapter. Mechanics subject. And so today we are going to discuss mechanics subject. So without wasting any time on any discussion, let's start the mechanics. Okay. So see the mechanics. Okay, for GATE exam. Okay, GATE exam. Okay. So, I will uh, go quickly through the all the theory parts, and we will do a lot of problems. Okay. So, first let's discuss all the basic points in the mechanics. Okay. So, the first thing is that what is mechanics? Okay. The what should be the definition of the mechanics? Okay. So here I have written the mechanics definition, and it goes like the branch which deal with the study of a state of rest or motion caused by the action of forces on the body is called a mechanics. Okay, so it's very simple. Like if you have any body like uh, this, or could be anything, and if you applied a force here, okay, so if you applied a force and the force is large enough so that this body can make a motion, so like in the course of mechanics, we will study how much force should be applied, how the motion goes after applying the force, how much force will be required to start the motion or to stop the motion, or everything is all about things come in the mechanics. This is a very simple example. So very complicated systems like combination of forces, combination of motions will come in this topic as well. Okay, so so one more thing that we are discussing here is only Newtonian mechanics. Okay. So Newtonian mechanics means what? The mechanics which are applied in macroscopic objects. Okay, macroscopic objects. Okay, so mechanics means that only in our case for mechanical engineering students. So I may forward to explain that this is yet exam for mechanical engineering. Okay, so we are going to discuss all things in perspective of mechanical engineering only. Okay, so what I am telling is like Newtonian mechanics. So the Newtonian mechanics means the mechanics which are valid for the macroscopic objects, okay? And for microscopic objects, the objects which are very small as compared to the objects that we can see in our real life, and there the quantum mechanics is valid, okay? So quantum mechanics, we have not to drill anything about the quantum mechanics, so we are only discussing about Newtonian mechanics, okay? So some classification is done in Newtonian mechanics, so we will discuss now. So what are those classifications? Okay. So the first one is sorry, static. Okay, static mechanics or static Newtonian mechanics. Okay, static. So what does static you know like what this branch consists of? Okay. So statics is the study of forces and conditions of equilibrium of material bodies at rest subjected to the action of forces. Okay. So let's suppose one body is there. Okay, yeah, suppose one of your friend applying force here, let's say F, okay, and from the other side as well, you are applying a force here, F as well, okay. So now, as you can see that from the Newton law equation, sum of force is equal to mass into acceleration on the body, okay. This is the how do you say free equation of this body, okay. So now, since total force is one, let's suppose this direction we are taking as a positive and this direction we will take negative. Okay. So positive plus negative is 0. Okay. So mass into acceleration. So that means mass is constant, so acceleration will become 0. That means the body is in equilibrium. Okay. That means whenever your body is not moving, that means it's static. And even though you are applying a force and the body is in static, then that branch is known as static. Okay. And the second one is dynamics. Okay, dynamic or dynamic. So just opposite of that statics, that means whenever you apply a force on the body, okay, and let's suppose if you are applying a force here, F, and the body are having mass m, then the body will do accelerate with acceleration F by m. value. Okay, this means the body is in the motion, it's not static or it's not in equilibrium, so that's why it's came under dynamic. So in dynamic two things comes, the dynamic branch itself can be classified into two ways. The first one is kinematics, okay, and the second one is kinetics, okay. Kinetics. So in kinematics we will deal with space and time, space and time. So here we are nothing to do about the forces. Like if a body is in the motion, okay, let's suppose I'm explaining with the figure and examples. Okay, some body is there, mass, and it's moving with the acceleration a, or say let's suppose velocity v. Okay, and it will travel a distance d. It taken time t. So even we will deal with these values and the variables and the equations, a, acceleration, velocity, time, and space. So that is known as kinematics. That means we are not involving force here, okay? We are not investing force here at all. So no force involvement, okay? Now here we will study the motion with the involvement of force. Then that is known as kinematics, okay? Kinetics, sorry. No, not of force. Force will be involved there. So that we will discuss how much force is required and everything. Okay. And now another most important things came here is deformation of body. Okay, and action and reaction. So we will take the same example that we have taken in the statics, that means this case. Okay, so let's suppose same case, this will, with this we will take a, let's suppose one body is there. Okay, okay, and so let's suppose your friend has applied force F from that direction and you have also applied a force F from this direction. Okay, means both forces are opposite in sense. Okay, so now what we can say that if you are seeing yourself as a doing action, like means you are doing work something, okay, work or something, like you are applying a action. So in this case this one is action, okay, and since the body is not moving, that means someone is doing reaction according to you. When you applied any action, I mean any force or work or thrust, anything, so in perspective of yours we are telling that as an action, but in case of friend perspective you are doing reaction and the friend is doing action. So like this is a pair of action and reaction forces, okay. So now I guess you can understand what's action and reaction forces. That is the basically Newton third law that we have studied in our school days. So action and reaction, you got it, okay. Now we will learn the deformation of body in this case from this example only. So let's suppose any material in this world having some deformability in there. I mean, if you like, if you take anything and you will apply a hammer over it, it will get deformed. Okay, that means there is some material properties there in the any particle or any object in the world which can get deformed. So after applying forces, okay. So that's basically like that's a tendency of any object to like protect itself from motion. Like if the, we can see this body is not moving, not doing any motion, okay, no motion, right? So since body is not doing any motion, so it had to do something, like some forces are applied. It has to do something, like because both of you and your friend both are doing some work, so something might have to happen. Otherwise, like both are of you are applying some energy, so some energies will have to get somewhere. Okay, so in that case, the body is not moving, and you people are applying forces continuously on the object. The body will get deformed. Okay. The bot, sorry, this would not be like that. It will deform something like that. Okay. Uh, so now the body will get deformed. Okay, that means a body which changes its shape or size under the action of external forces, like you and your friend, this and this. You people are applying any external forces, and thus the body get changes. Okay, so this is the energy that you have given, that is gone as a deformable energy. Okay, that is getting stored in the material, and that came as a deformation of the body. Okay, so I hope deformation of body, action and reaction, you got it. Okay, now another thing come, that is tension. Okay, so I'm explaining it in very simple ways with the, the help of example. Okay, so let's suppose one what to say, one thread is there that is tightened very tightly between 2 points, one and two. Okay, so now it is very tight, right? As I told you, it's very tight. So some tension will develop in the rope, okay, and it will be in opposite direction to the point. Okay, so it's like a pulling forces. Okay, like this is the points where it is attached, and here it's providing pulling. Okay, pulling action, pulling, pulling, right? So it's the pulling forces which is acting through a string when it is very tight, and it's act in the outward direction. Okay, outward direction means we are talking all thing about pivoted point. Pivoted point means point one and two. Okay, now I guess you have understood the thrust, tensor, sorry, tensor. So it's very easy. Now we will see the thrust. So same thing as tension, but instead of pulling here, pushing will happen. I mean, the force will get applied in these directions along the pivoted point. Okay, so pushing is performed there. So nothing much to worry about. Same as a tensor. Okay. Now we will see what's the force. Okay. So force may be defined as any action that tends to change the state of rest or inform motion of a body on which it is applied. Okay. I mean, force is something that like force having the capability to change any body from rest to motion or motion to rest. So, let's suppose a body is there with aim, and if you applied a what to say, force here, this will get a motion with the acceleration of F by m. Okay, so the force having a tendency to move a static body with acceleration something, some acceleration value, that is always. And if a body is moving, let's suppose m body is moving with velocity v, and even if you apply the force here F, it can get a stop. Okay, because the body will get decelerate because of the force, and it will get a stop eventually. Okay. So that's the tendency of the force that the force has can do two types of works. Okay, either it can make a rest body to motion and the motion body to rest. Okay, and for force there are four characteristic points to define a force. Okay, the first one is magnitude, like second one is point of application, third one is direction, and fourth one is line of action. Okay, so I will explain it you in a figure. So let's suppose a block is there with mass A. Okay, okay, and some force is applied, let's suppose A. Okay, now the first characteristics of the force is magnitude. Okay, so let's say uh, how the magnitude will get defined in this figure. Okay, so uh, let's suppose so the length of this arrow, how much is the length, will represent the magnitude. Okay, g magnitude. Okay, so the amount of the length, if the length of this let's suppose length of this arrow is a, and if you draw a another arrow with length 2l, that means the force applied here is doubled. Okay, that means doubled force is applied here. So the arrow length will represent the magnitude. And the point of application means this point, the point where arrow is striking, or uh, like the arrow is pointing towards some point. Okay, let's suppose in this case it is P. So that is known as point of application. And the direction, that is force vector quantity. That means force vector quantity, that means it is having both magnitude and the direction. Okay, and the direction will be represented by this arrow. Okay, arrow. And the line of action is if B make a line along this arrow, then that is known as this line is known as line of action. Okay, line of action. One more point I have to include is, like if a force is applied like this. Okay, this here, then see, the arrow is pointing toward this direction, so direction it will be in that direction, and the magnitude will be uh, is equal to the amount of length of this arrow. Okay, and even though the tail is pointing towards some point in the body, then this is also known as point of application or point of action. Okay, uh, so I hope force, tension, and thrust have been clear to you. Okay, now one more important things come, that is known as sorry. system forces. Okay, so what do you mean by system of forces? A system of forces or a force is the set of forces acting on the body or a group of body of interest. Force system can be classified according to the orientation of the movement. Okay? So like a system forces means, let me explain it. Yeah. So system of forces means, let's suppose a body is there, okay, or a single body, okay, and here you are not you are, I mean, plenty of forces are being applied here. Okay, that means in a single body, plenty of forces are there. So that is known as system of forces. Or otherwise, let's suppose one body is there, two bodies there, three bodies there, and even though a single force is applied, so one force will apply to this object A, let's suppose, then A will apply a force on B, and C will also apply forces on B. So there are also plenty of forces is applying. So like more than one forces will be there in any cases, then that is known as system of forces. Then so in this case, a single body is there, but the forces applying are varying. Okay, too many forces are there. That's why it's a system of forces. In this case, multiple bodies there, but only single forces are applied. But due to the contact between these bodies, plenty of forces get generated. That's why it's also classified as a system of forces. Okay. Now, the force system can be classified according to the orientation of the line or anything. So I have taken a picture of that and I have attached here for the different system of forces. Okay, so the system of forces can be, first it can be classified as a two parts, coplanar and planar. Okay, so what do you mean by coplanar? Let me explain you. So let's suppose some plane is there. Okay, let's suppose xy plane is there. Okay, and if all the forces are there in this plane only. Okay, so then this is known as plane, coplanar. That means all the forces are present in a single plane. Okay, then that is known as coplanar. But whenever, uh, say suppose another xy plane is there, x, y. Okay, so it can be said that some forces are there in the plane, but some are there outside of the plane. Then that is known as non-coplanar forces or space forces, because it is available, it is distributed in all over the spaces. Okay, and simply we can say that coplanar means 2D forces and non-coplanar means space forces. That means 3D forces. The combination of them will be a 3D forces. Okay, and now the coplanar forces can be divided into collinear and concurrent forces. Okay, what do you mean by collinear forces? Let me explain it very simply. One line is there. Okay, and if all the forces, that means there is system forces, that means plenty of forces will be there. Okay, too much. So all the forces that is there available in the system of forces will be over a single line only, then that is known as collinear forces. And concurrent forces means all the forces are pointing toward, uh, whether it's tail or head, doesn't matter, but it should be pointing toward a single point. That is known as concurrent forces. Okay, so that same applies for concurrent in the coplanar and in the non-coplanar. And the difference is that only in current coplanar, all the forces will be there in a single plane, and in this case, all the forces will be there in the space. Okay, that should not be in single plane. Okay, okay, and now the classification comes as a non-concurrent. Okay, so non-concurrent forces. Non-concurrent can be classified as a two parallel and non-parallel forces. Parallel means you have studied in the class. Okay, in a school days, like parallel means parallel forces having a line of action in a parallel manner, then that is known as parallel. And non-parallel means they are not having it like this. Okay, they are not parallel to each other. Okay, then that is known as non-parallel general forces. Okay, unlike parallel means, see, they are parallel for sure, and if you observe that all the forces having a tail in the same side and head on the same side, but in unlike parallel, someone having a tail there and here, so that means all the tails are not on the same side, all the head on not in the same side, then that is known as unlike parallel. Okay, so here we have done with the classifications of the forces, and here are the examples. Some examples are there for the system of forces. Okay, Okay, so you can read the system of the forces examples by yourself. I'm not going to explain this. This is very easy. I'm just I think of that as it is an important thing, so I just uh, cut and pasted the picture here. Okay. Uh, One more small topic is there. Uh, Here it is. Okay, so this topic is representation of forces. Okay, so how we will represent the any forces. Okay, so representation of forces means a straight line represent the line of action of the force 1 kilometer. Its length. Let me explain you with the one example. Okay, so let's suppose a body is there. Okay, okay, a straight line represent the line of action of the forces. This line, if we extend it like somewhere else, that means this line represent a line of action. Line of action. Okay, yellow. And length represent its magnitude. I have already explained this that the length of this arrow is magnitude. Okay, the direction of force is indicated by the placing an arrowhead on this straight line. If the arrow is this direction, that means force is applied at point A in this direction. Okay, and if arrow is like this, then the force will apply in this direction. If the force is in sorry arrow in this direction, then force will apply in this direction. Okay, so that's all about the force representation. I hope you find this video very helpful. Let me comment it out how we can improve this. Okay, so till then, goodbye and keep learning.